Screen is visible. Is screen is visible.
Yes, sir.
Yeah. See, this is the network given. Switch and resistance of 1000 ohm and capacitor of 1 microfarad. Okay, 1 microfarad. This is ohm. This is the switch. Voltage is given as 100 volt. Okay, current it will flow when switch is closed. Okay, this is the network given. Question is, in the network the switch is closed at t equal to 0. Switch closed at t equals to 0. Okay, with the capacitor uncharged. Capacitor is uncharged. Capacitor is uncharged. Switch closes at t equal to 0. Okay, find the value for I di by dt and d square I by dt square at t equals to 0 plus. This is the question. Network is given. What they are saying, the switch is closed at t equal to 0 second with the capacitor is uncharged. It means initial condition for the capacitor V 0 minus is 0. Find the value for I di by dt and d square I by dt square at t equal to 0 plus. Okay, now we know that at t equal to 0 minus, capacitor uncharged in the sense initial conditions at 0 minus second are 0. That is, voltage across the capacitor at 0 minus is equal to 0 because capacitor uncharged, and the current flowing through capacitor at 0 minus is 0. Initial conditions are 0. Now at t equal to 0 plus, we need to redraw this circuit at t equal to 0 plus. At t equal to 0 plus, capacitor will behave as a short circuit. Inductor is behave as a open circuit. Okay, here in this problem capacitor is given. Okay, last problem what you have seen, in that inductor is given. There we have assumed at t equal to 0 plus, inductor will behave as a open circuit. Here capacitor short circuit. Okay, I am going to redraw this circuit. T equal to 0 plus. Okay, capacitor short circuit. Now values 100 volt, 1000 ohm. Okay, here VC 0 plus, I up 0 plus. Okay, now VC 0 plus, short circuit voltage this one, VC 0 plus is equals to short circuit 0. Then I 0 plus, the current at t equal to 0 plus. Tell me. See, resistor is there, voltage is there. What is the current? This current I am asking. This current. Tell me. See, simple Ohm's law. Apply and tell me the value of I 0 plus. If you are not responding, I am going to cancel the class first. Hundred volt is there, 1000 ohm resistance is there. What is the I?
10.
10. See, only 10 members are joined now, and they are also not answering.
So 0.1.
0.1. 100 divided by 1000. V equal to I R, I equal to V by R. V is 100 divided by 1000 resistance. That is 0.1 ampere. Okay. Now next for T is greater than 0. Okay. I am going to read on the circuit. T greater than 0. Okay. This is 100 volt. This is 1000 ohm. This is 1 microfarad. I of T. Apply KVL. Current is flowing like this. Apply KVL. Plus minus. Apply KVL. Minus to plus. Plus 100. Then plus to minus minus 1000 I. Then plus to minus minus. Current flowing through capacitor. What is the expression for current flowing through capacitor? 1 by C 0 to T I dt. Here 1 by C is 1 microfarad. 1 divided by 1 into 10 raised to minus 6. 0 to T I dt is equals to 0. Okay. First what I did, I have assumed the initial condition T equal to 0 minus. See, I am not assuming. In the question itself they have given that initially capacitor is uncharged, in the sense initial conditions at T equal to 0 minus Vc 0 minus I 0 minus are 0 0, and at T 0 plus I am reading the circuit that I know the capacitor is short circuited at T 0 plus and inductor is open circuited at T 0 plus. Okay, then I have written Vc at 0 plus Is 0 plus, that is 0.1 ampere I got. Now for T is greater than 0, okay, I retain all the elements resistance capacitance as it is and applied KVL. Minus to plus 100 volt minus 1000 I minus 1 by C 0 to T I dt, that is 1 by 1 microfarad 0 to T I dt. Okay. Now differentiate this equation. Differentiate this KVL equation. I'll get 0 minus 1000 di by dt. Okay. Here if 10 raised to minus 6 in the denominator comes to the numerator, plus 10 raised to minus 6 minus 10 raised to plus 6 into, if I am going to differentiate the 0 to T I dt, it will become as I equals to 0. Now I got di by dt is equals to minus 10 raised to 6 divided by 1000 I. Di by dt is minus 10 raised to 6 divided by 1000 I. Okay, now at t equal to 0 plus, now at t equal to 0 plus, at t equal to 0 plus, okay, I got this di by dt. Okay, this I am going to write here. Di by dt is equals to minus 10 raised to 6 divided by 1000 into I. Now what I am going to do? I am going to put t equal to 0 plus in this equation. That is di by dt at 0 plus minus 10 raised to 6 1000, that is I 0 plus. Okay, we know I 0 plus. See here. What is I 0 plus?
0.1 amperes.
0.1. Yes, here I am simply substituting this minus, okay, 10 6 and into 0.1. I'll get minus 100 ampere per second. Why? Because di by dt ampere per second. Okay, now if I'm going to differentiate this equation di by dt, again I'll get, see here, d square d I square, that is d square I by dt square equals to minus 10 raised to 6 divided by 1000 di by dt. Okay, we know the value di by dt is 100, so minus 100 10 raised to 6 1000 into, this is minus, okay, minus 100, I'll get, how much I'll get, minus minus get cancel, 10 raised to 6 into 100 divided by 1000,
So 10,000.
not 10,000, 1 lakh, 10 raised to
Sir.
5, 10 raised to 5 ampere per second square. Okay, in question they have asked I di by dt t square I by dt square at t equal to 0 plus. Okay, at t equal to 0 plus, we found I 0 plus 0.1 di by dt at 0 plus minus 100 ampere per second, then d square I by dt square, that is 10 raised to 5 ampere per second square. Okay, now what we'll do, we'll solve one problem involving inductor as well as capacitor. Okay, first problem is with inductor, second is the capacitor. Now we are going to solve involving capacitor as well as the inductor. Okay, see MSc3 this all portion will included. Okay, yeah, this is the network given, values, no, 10 volt, 10 ohm, 1 Henry, 10 microfarad I of t. This is the network given. Assume all the initial conditions as 0. Find I di by dt and t square I by dt square at t equals to 0 plus. Okay, what we are doing, this is a network given. In question they are mentioning that initial conditions are 0, all the initial conditions 0, that means I 0 minus and V 0 minus are 0. Okay, we need to find I di by dt and d square I by dt square at t equal to 0 plus. Okay, first given data, what is that, at t 0 minus, okay, I0 minus is equals to 0, V0 minus is equals to 0. This is given data. Okay, now we need to find at t equal to 0 plus. Okay, at t equals to 0 plus. I'm going to redraw this circuit at t equal to 0 plus. What will happen? There is no change in the capacitor resistance. Okay, we are going to drawn as it because voltage and current are change instantly in the resistance. Okay, at t 0 plus, my inductor will become as a open circuit and my capacitor will become as a short circuit. Okay, if you listen the first class of this, you better know that one. Now this is 10 volt, this is 10 ohm, inductor becomes open, this capacitor become short. Okay, now I0 plus, this is a circuit I have redrawn at t equal to 0 plus. Fine. Now current through this circuit is I0 plus how much? I0 plus.
So 1 ampere.
See, there is no closed path. Inductor is open at t equal to 0 plus. Current will flow. Hmm? No, right? Open circuit. There, so I0 plus is 0. Then Vc 0 plus. Always remember we are going to calculate the voltage across the capacitor, current through the inductor. Okay, I0 plus 0, Vc 0 plus short circuit 0. T0 minus initial condition 0, T0 plus also I0 plus is 0, Vc 0 plus is 0. Now here comes for T is greater than 0. This one I will remove for. Okay, for T is greater than 0. Hmm. This is a circuit I am redrawing. Okay. 10 volt, 10 ohm, 1 Henry, 10 microfarad, I up T. Apply KVL. This minus current entering plus minus plus minus plus minus. Apply KVL. KVL for the above circuit. Yeah, please. Minus to plus, plus 10. Minus to my plus to minus, minus 10 I. Then current through this inductor, that is L di by dt. Correct? L is 1 here. 1 di by dt. Okay. Coming to capacitor, current through the capacitor. 1 by C 0 to T I dt. That is plus to minus minus 1 by T 10 micro. Okay. 0 to T I dt is equals to 0. I have just applied the KVL for the circuit. Okay. Now at T equal to 0 plus. At T equals to 0 plus. What I'm going to do, I am just substituting 0 plus in this equation. Okay, 10 minus 10 I of 0 plus, then 1 di 0 plus by dt. Okay, then this one minus 1 by 10 into 10 raised to minus 6, 0 to t I of 0 plus by dt is equals to 0. Okay, now we know I of 0 plus is 0. Okay, we have calculated. Fine. Now what I'm going to do, I of 0 plus this is 0, this will get cancelled, this is 0, correct? Ti, okay, see, I of 0 plus this will 0, in the sense total whole term will get cancelled. Now we are going to left with 10 minus di 0 plus by dt is equals to 0. Now I am going to get di 0 plus by dt is equals to minus, this is minus that side, now tell me the value for this. Di by dt 0 plus how much? Plus 10 or minus 10? Di by dt plus, okay, 10 ampere per second, correct? Now differentiate this equation, I'll get constant 0 minus 10 di by dt, then minus 1 d square I by dt square, then minus 1 by 10 into 10 raised to minus 6, 10 raised to minus 6 I 0 plus is equals to 0. Now again substitute at t equal to 0 plus in this equation, that will become, wait, substitute t equal to 0 plus minus 10 d I by dt 0 plus d square I by dt 0 plus minus 1 divided by 10 into 10 raised to minus 6 I 0 plus equals to 0. I'll get, after simplifying this one, I'll get d square I 0 plus divided by dt square is equals to minus 10 into 10 minus 100 ampere per second square. Okay, for all problem like this initial conditions, okay, if they have mentioned uh, capacitor uncharged, current flowing through inductor is 0, then we are going to assume all the initial conditions t equal to 0 minus as 0 0. Then we are going to rerun the circuit for t equal to 0 plus. At plus, inductor will behave as an open circuit, capacitor will behave as a short circuit. Okay, depend upon that we are going to calculate I 0 plus and phi 0 plus. Then next condition is for t is greater than 0, we are going to redraw the circuit with keeping all the inductor capacitance resistance as it is in the circuit, and the current flowing through that circuit will be I of t. Then apply the KVL, find out di by dt, then differentiate that KVL equation, we are going to get d square I by dt square. In question they are going to ask find I di by dt d square I by dt square at t equals to 0 plus. Okay, now one more problem. Yeah, parallel circuit. This is a network given. Okay, current is 1 ampere. There is a switch here. V of t 1 Henry and 100 ohm. Okay, t equal to 0. The switch is open at t equal to 0. At t equals to 0, switch is opened. Okay, calculate phi dv by dt and d square v by dt square at t equals to 0 plus. Okay, now we know at t equals to 0 minus t equal to 0 minus initial current flowing through this inductor, because see at t equal to 0 switch is opened. Okay, so t equal to 0 minus initial current flowing through the inductor, that is IL is equals to 0. At t equal to 0 switch is open. Calculate phi dv by dt and d square v by dt square at t equals to 0 plus. Okay, initial current flowing through the inductor, that is IL 0 minus is 0. There is no initial current will flow in through the inductor just before the switch opened. So we are assuming IL 0 minus is equals to 0. Okay, now at t equal to 0 plus, at t equal to 0 plus, I'm going to redraw the circuit. T equal to 0 plus, inductor will behave as, tell me how inductor will behave. T
Open.
equal to 0 plus, open circuit, and resistance resistance as it is, because the current through resistance instantly change in accordance with the voltage. Okay, here this is 1 ampere, this is IL 0 plus, this is phi 0 plus at t equal to 0 plus. Okay, this is 100 ohm. Fine, open circuit due to at t equal to 0 plus inductor will behave as a open circuit. Okay, now I 0 plus is equals to 0. Phi 0 plus is equals to, tell me the voltage, this voltage. It's a simple Ohm's law. We need to find this. It is there. See, this is open circuit. You remove it, means don't consider. Okay, what is the voltage at this point? V0 plus. 100 into 1. 100 into 1. That is 100 volt. Okay, now for t is equals to 0 plus we have calculated. Now t is greater than 0. Okay, see here only I will modify t is greater than 0. Switch, while writing t is greater than 0 we are not including the switch. Okay, this is the circuit for t is greater than 0. T is greater than 0. Okay, now apply KCL. This node, apply KCL at this node. Yeah, apply KCL at node. See, I am writing this node here as well as this is, there is no difference. Okay, now I will read on this circuit. At t is greater than 0, 1 ampere, then this is 100 ohm, 1 Henry, 1 ampere, V t. Okay, apply KCL, apply KCL at node, this node A, node A. I'll get V divided by 100. This is V divided by 100 plus 1, it's current flowing through this, 0 to t V dt is equals to 1. Means I am just applying KCL here. Fine. P by 100 plus, this is current 1 by L 0 to t V dt equals to 1. Then 1 by 100, 1 by 100 see this one you got right how I am writing this one. P by 100, this is nothing but this is expression for 1 by L 0 to t V dt. Current in terms of voltage. I am analyzing this circuit, this branch separately. I am writing the current equation. Okay, then I am writing this one by analyzing this circuit separately. I am writing this equation. Okay, already current flowing in this branch is 1 ampere, 1 ampere. Okay, now simply now I got V by 100 plus 1 by 1. Okay, leave that one. 0 to t V dt is equals to 1. I got this. Okay, now I am going to differentiate this equation. 1 by 100, okay, dV by dt plus, if I differentiate 0 to t V dt, I'll get V constant. This is 0. Now at t equals to 0 plus dV by dt 0 plus. Okay, that is nothing but, okay, first I am going to 100 plus V0 plus is equals to 0. Okay, now dV by dt 0 plus is equals to minus 100, means minus V0, that side minus 100 V0 plus. We know V0 plus, that is 100 volt. At t equal to 0 plus, we have calculated V0 plus as a 100 volt. Okay, I am just going to substitute here. Minus 100 into 100 dy dt by 0 plus is minus 10,000 volt per second. Okay, again what I'm going to do, I'm going to differentiate this equation. Okay, I'll get 1 by 100 d square v by dt square plus dv by dt is equals to, okay, finally what I will get, d square v by dt square 0 plus equals to, I know the value, minus 10,000 volts per second for dv by dt 0 plus. So minus 100 dv by dt 0 plus, that is minus 100 into minus 10,000, that is plus 10 lakh, that is 10 raised to minus 6 second square. Okay.